Hello everyone, today I'm going to talk about the example that we're going to have for the exam on Monday. So now we have example number 4 that we're going to find the complex power for each load and draw the power triangle. Yes. So you know that complex powers consists of S equals to P plus or minus JQ, and it depends. So we have load 1, load 2, and load 3. And we know that all the loads are different in the PF, which is leading or lagging. If it is leading, it means that the load is capacitive load, and if it is lagging, it means that it is the inductive load. You can remember by the keywords like this, because when you have to calculate for the Q, you have to be like the minus sign or the plus sign, because overall in the end it is in the square root, so it is plus or minus. So you have to know the keywords that leading is capacitive, which is minus, and lagging is plus sign, which is inductive load. So for load 1, we have seen that it is P equals to 12 kilowatts, and PF, which is a power factor, is 0.866, which means that it is quite a good motor. It's a good load, because the PF is quite high, and you can see that the S is from the P over PF, because PF comes from P over S. You have to remember that P over S, it is the easiest key to remember about the power factor already. So you have to calculate, and after that you can find the Q, and the Q is also easy to find because the Q is just the square root of S squared minus P squared from the Pythagorean rule. So we have the right triangle, and we have the S, P, and Q, and the theta angle. So we have seen the formula like so many times already. So it's like S squared equals to Q squared plus P squared, or you can do it by the trigonometry as like the Q equals to sine of theta multiplied by S, which means that it comes from the sine theta equals to opposite side over hypotenuse, which means that S over Q. So we find Q, it is Q over S, and then if we find Q, it means that S multiplied by sine theta, and it means that you can remember very easily. It's so katoa, it's like O over H means that opposite over hypotenuse. That is the easiest thing to remember about the trigonometry about the right triangle. So now we move on to the Pythagoras, because if we want to find by the Q equals to sine theta multiplied by S, which means that you have to find the angle again by the reverse of cos theta. So it's a long way to do. So you just like do the Pythagoras, it's like the square root, and it's done. So allow me to take some time to calculate the numbers, and finally we get the number, which is this number. Why it is a minus sign, I already mentioned it before. It's that because the minus sign comes from the capacitive load, and the capacitive load is like the keyword is leading. So when it is leading, it has to be the minus sign, capacitive load. Then we can move on to load number 2. So actually load number 1, we only have to find the P, the S, the Q, and the PF of it. That's it. Then we can find the load number 2. The load number 2, we have P, which is already written in the example, which is 16 kilowatts. Don't forget the unit. I forgot the unit already. And the PF is 0.85, which is also another good whatever it is, load or motor or anything of the thing is, it is a good thing because the power factor is between 0.85 to 0.895. It is a very good thing to have a motor or to have the load. Okay, whatever it is. And so we have the S, which is the apparent power, 16 over 0.85. You know where it comes from, P over PF, and the unit is kVA. Then we find the Q as normal. And here we have plus because it is inductive load, because it is lagging. Laggings mean inductive. Inductive means positive. Positive means plus sign. Yes. So after this, we are going to find everything for load number 3, because load number 2 we already have the P, the S, the Q, and the PF already. So now in load number 3, we don't know the P, the true power of it. We need to find the P by the given thing, which is the Q and the PF. The Q is 20 kVAR. You have to remember that R means stands for reactive, and Q is the reactive power of the load. So if you see that unit, you know that is the apparent power. Oh, sorry, it is the reactive power. And there is the PF that we can find zeta from it, because we have no way to find it by the Pythagoras theorem. So when we find the angle of it, don't forget to make sure it's in degree or whatever it is. And whenever I do the exercise, I like to draw the right triangle for me to realize what kind of sine, cos, or tangent that I need to do, because I always get confused which side is which side. So yeah, tan is toa, which means that O opposite over adjacent means that Q over P. So when it is a Q over P, I can find the P from the Q and the angle that is given from the PF. So without any further hesitation, I find the P from this formula and I calculate it, and it is something around 15. Yes, I guess it right. So after getting the number, the value of the true power, we're going to find the apparent power, which is the S, which is 15 over 0.6. At this point, I do not need to use any kind of trigonometry rules like the sine, cos, because I already know the P already. So it's very easy, just like the normal P over PF, 15 over 0.6, it is 25 kVA. Then we know that the complex number is from the S, the apparent power, equals to true power plus or minus JQ, which is the reactive power. Allow me to correct this because I wrote it wrong. So it's supposed to be P plus or minus JQ. So now after you're making sure the formula is right, you follow up by completing the formula by S1, which is load 1. We have the complex power, which is P12 plus or minus. So in this case, it is minus because it is capacitive load. It is leading, and leadings mean capacitive load, which is negative sign. So the number is 6.92 kVAR. And then we move on to the S2, which is 16 plus 9.915 J, which is inductive load, leading, lagging stuff. You have to remember all of those. We also have the S3, which represents for the load number 3. So now we can draw the right triangle, which is the power triangle that represents each load. Sorry for the really messy right triangle that I'm trying to draw, but yeah, you have to draw it nicely on the exam paper. So now we have a nearly perfect right triangle, which you can write down all the numbers. Actually, you don't really need to draw it one by one. It's like in the end, you can just draw the bigger one, but this is just like something to illustrate the imaginary vision of what's going to be, because there are plus Q and minus Q. Okay, so it's like label everything that is important for you guys to actually plus and minus. So in this case, you can only plus for plus and minus, like the subtraction and the addition, for the P and Q only, because in the end, the S, you have to do the stuff with the Pythagoras the square root, something like that, so you cannot plus and minus s. I will show you why. No, I will show you why. I will try a trial why it is not, because it's not equal. Yeah, you cannot do that, just in case you might think you can do, but actually you cannot do, okay? So it is, we have the positive plus positive, and then you minus the negative. That's the simple things, the basic things that we have all known from primary school. Just writing for you guys too, yeah. So we have P, which is the true power, which is the, we can say the true power, the active power, any power that is true to yourself, it is true to the load, it is not added with anything, it is the real power, the real beauty of the power. Okay, so in the end it is 43 kilowatts watts, and we have yeah, it's a Q, so Q we can plus and minus, which is, don't forget the minus sign of the capacitive load, because the capacitive load is always minus. It's a long story. If you really want to know why it is negative, you can DM me anytime. Oh wow. Okay, so we have sorry, I have to calculate it first. Okay, we have 22.995 kVAR. And then finally, the S is from the P square plus Q square. Allow me some time to do the calculation. I'm not really that good in you mean like, I mean the calculator thingy, so I need some time. So it is 48.762 kVA. There's no R because it is S. Yeah, that makes sense. So now I'm just trying to tell you that if you plus all the numbers together from S1 to S2 and S3, you will get around 57 something, which is not 48. So I'm just trying to say that it is a right triangle and it is the hypotenuse. You cannot just plus and minus as you wish. So it is not R. I mean, if you want to try the other way around, that S1 plus S2 plus S3, you will not get the number, okay? So please don't plus or minus the subtraction, anything with the apparent power. Okay, so we have the right triangle, the big right triangle that you actually need to measure it really carefully, because in the end it is the true power of the whole circuit, if I'm not wrong. So we have S equals to 48.762, Q equals to 22.995, and P equals to 33. Thank you. That's it. Thank you. Good luck.